Welcome back to a new video lecture, and in this lecture we discuss a new topic, and it is related with the estimation of culvert. Actually, what is a culvert? So here you can observe a diagram that is related with the culvert. So it is a small channel which allows the water to flow under a road or some rail likewise. So here you can observe the culvert is constructed here. So our aim is to calculate the total quantity of this particular materials required for this particular construction. So through this video lecture, we discuss about how much quantity required for constructing this type of culverts. Okay, so now we move on to our today's question. So prepare a detailed estimate of a slab culvert of 1.5 meter span and 4 meter roadway. From this following details are also given here. So please go through these details also. Okay, so while doing problem, you will get more clarity regarding what all things are written here. That is foundation concrete, that is 1:3:6 ratio given. Then first class brick is also used for this particular construction. Then RCC slab. Then some thickness for the road cover, wearing coat is provided likewise. Okay, so actually if you observe through this three-dimensional figure, you will get more clarity regarding what all things is written here. So actually we need to find out this quantity, that is brick masonry here. So what all things as we did here, the same is repeated here also. Okay, so if you are taking something, you have to multiply with the 2 always. Okay, and in the initial state there is a slab is provided here, and this water is flowing under here, under this culvert portion. Okay, so this is the road surface. Here you can observe this, the road is provided here, and this is one more diagram which represents the 3D view of this culvert portions. And before going to the diagram, our aim is to trench or excavate the portion. Okay, excavate the soil. So some depths are, so the figure shape will be in this format. Okay, this C type you have to excavate. Okay, in this way, and from the drawing you have to calculate those values. So now we move on to our drawing. So here in your question or in your exam point of view, you only will get this diagram only, no 3D diagrams. Okay, so collect maximum details from this diagram. So after going through this three-dimensional diagram, you will get more clarity regarding what all things are written in this figure. So here you can observe that this is your trench, this is your culvert portion, that is C type portion is written here. That is, here you can observe that, closely observe this value, it is going to be 4.8, and here some 15 centimeter is provided here, and here also 15 centimeter. So if you add up those values, you will get 5.1 centimeter. Okay, so that is the total length. Then if you observe clearly, what about this dimension? It is going to be, if you observe this value, it is going to be 0.7. This width, it is going to be 0.7 throughout. Okay, 0.7 throughout. Then the height, it is given us this ground line, below this ground line, this 30 centimeter, and here also 30. So you will get 0.6 centimeter. So that is the case. So if you observe here, this 5.1 is written here, the lengthwise. Then the height, it is taken as, the height it is taken as 0.6 meter, and this width it is taken as 0.7 meter, and this dimension it is taken as 1.2 meter. Okay, once again we move on to this, how you got this 1.2. So it is clearly written that the 1.2 is clearly written in this drawing. Okay, this 1.2 meter. Okay, here you can observe 1.2 meter is written here. So if you are dividing them into rectangles, different rectangles, then it will get more clarity. So first of all, you have to calculate this abutment portion. Then this portion, it is actually called the wing portion. These both sides are wing portion. So in these cases, how many wing portions are here? 4 numbers. So you have to calculate 4 numbers values. And the abutments is 1 and this one is 2. So that is the case. And while doing problems, we will go through these diagrams also. Okay, these diagrams are also very important for the calculation purpose. Okay, so this is the first calculation, that is the excavation portion. So you will get the values in this way, that is earthwork excavation in foundation. This abutment values is actually, this abutment, it is going to be numbers 2, and the length it is 5.1, then 0.7 breadth, then height it is 0.6, and here the wing walls, it is going to be 4 numbers, then length it is 1.2, breadth 0.7, and height 0.6. If you multiply, you will get 6.3 meter cube. So that is the first step. Then you can visualize some more clearly through this diagram. Then after that, our next aim is to go through the cement concrete. Okay, so just a second. So if you observe here, after this excavation, there is a cement concrete layer is provided here. So you can note down from this diagram, this height, it is going to be 30 centimeter, clearly mentioned there. So that is only difference. So if you go through the 3D diagram, you will get more clarity. So this is the case, that is we need to find out this much portion, that is 5.1, and this breadth it is going to be 0.7, and the height of this concrete it is going to be 0.3 only. Okay, so some more clarity you will get from this diagram. Okay, so here also these abutments are going to be 2, that is this one 1 and this one 2, and here this wing portion 1, 2, and here 3, and this one is 4. Okay, that is the case. So the cement concrete for foundation, the abutments, it is going to be 2, and the total length it is given as total length 5.1, then 0.7, 0.3 height. The wing walls length it is 1.2, 0.7, 0.3. If you multiply, you will get 3.15 meter cube. Okay, then next our aim is to construct the first class brickwork. For that, please observe these diagrams, that is we need to find out this brickwork. So the dimensions are mentioned here. We have to give some space over here. Okay, some offsets are provided here, then only the construction of this brickwork to be started. Okay, so throughout there is some offsets are here. Okay, you have to start the construction after some distance. Okay, that is that we observe from the diagram. So after that, you have to construct up to certain height of 1.5 meter, and the distances, all things we will calculate from this SketchUp. Okay, so here you can observe that the first class brickwork need to construct. So if you clearly observe, it is mentioned this colored portions. Okay, so it is clearly mentioned the length it is going to be 4.8 meter. And what about the height? If you observe clearly, this is 30 centimeter here, then 100 centimeter is provided, then a 20 centimeter is provided. Okay, actually here if you observe, this brick portion is only up to certain portion. After that, a slab is actually provided. Okay, that we have to reduce at the end. So once again repeat, the length it is going to be 4.8. Okay, the construction to be started from leaving a distance of 50 centimeter to each sides. Okay, so 4.8, then height it is going to be 1.5 meter, that is 100 plus 30 plus here also 20, so 150 centimeter or 1.5 meter. Then if you check out this abutment, if you observe, the value it is going to be 0.4 or 40 centimeter. It is also clearly mentioned in this diagram, 40 centimeter clearly. Okay, so that is the case of this abutment. And if you observe the case of this wing walls, this dimension, actually this dimension has to start from, if up to here it is going to be 1.2. So 1.2. So here also some portion are here. Okay, so if you consider these portions, the distance it is going to be 1.2 itself, and this dimension is going to be 0.4. Okay, so this wing walls is actually 4 numbers, and abutments is 2 numbers. Okay, once again go through this diagram, 3-dimensional. This 4.8 meter, then this distance it is going to be, you are taking this dimension from here. Okay, 1.2 meter, and this width it is going to be 0.4, that you can observe from the diagram itself. Okay, it is already given that 0.4. So some more clarity if you observe through this diagram, 3-dimensional diagram. Okay, 1.5, 0.4, likewise all the dimensions are mentioned here. So the first 2 things is, that is the first class brick, 2 numbers is abutments is, total length it is going to be 4.8, then breadth it is going to be 0.4, then height it is going to be 1.5. The same is repeated, that is for the wing walls, total numbers it is going to be 4, then 1.2 length, then breadth 1.4, then height 1.5, you will get these values. So after that we have to place a slab over this layer. Okay, so actually in our calculation we have added this quantity also, so at the end we will reduce this quantity also. Okay, so here you can observe that the slab is placed over that particular portion. Okay, so we need to find out those slab quantity later. So actually the slab will be placed in this way. Okay, so after that we will construct this parapet over that particular slab. So in this way we will construct the parapet over this portion. So we need to find out the quantity of this brick. Okay, so here you can observe that the dimension is going to be this much portion only, this green portion only it is going to be, that is 4.7, it's the length, then 0.4 it is going to be the width, and 0.3 is the height. So from this we will observe the values, how you got that point, the height, depth, likewise all values. So here you can observe that the height it is going to be 0.3. So how you got that value, that is 20 centimeter is here, and over that a 10 centimeter wearing coat is provided here. So actually the height it is going to be 20 plus 10, so 30 centimeter, and the width it is mentioned here, that is 40 centimeter. So that is regarding the breadth and height. Then from here you can observe the length it is going to be 4.7, since you are reducing this for 10 centimeter from both sides. Okay, here also 10 centimeter, so for total 4.9 meter. So after that you have to reduce that value 10 centimeter, so you will get 4.7. This is the other cross-sectional view. Okay, so if you multiply these values, that is parapets up to curb, you will get, it is going to be 2 numbers, then 4.7 multiplied by 0.4, then 0.3, you will get 1.13. Okay, so that is regarding that particular portion. Okay, right now we have calculated the portion above this wall, that is this parapet wall, up to this portion. Okay, up to this quantity we have estimated right now. Okay, fine. So after that we need to find out the next portion, that is you have to leave some space and you have to construct in this way. Okay, so we need to find out this quantity in both sides. These are so 2 numbers, so we need to find the dimensions. So here also the length it is going to be same, 4.7, and the height you can observe from here, that is height it is going to be 50 centimeter. How we got that 50 centimeter? Actually up to here we need to find out, that is here it is mentioned that 60 centimeter, and you have to reduce this 10 centimeter from that, since we need to find out this quantity later. So 60 minus 10 you will get 50, so 50 centimeter, and width it is going to be 30 centimeter, and regarding the length it is going to be 4.7, so you will get that value also. So parapet above curb portion. Okay, above curve portion it is going to be two numbers, then 4.7, then 0.3 width, then 0.5, it is going to be the height. Okay, then above that one more layer, that is parapet coping. Okay, that you can observe from here, that is this 40 centimeter is outside projection, then the width it is height, that is going to be 10 centimeter. So we need to find that quantity. So the total length you have to take is 4.9. Okay, so here you have to take this 4.9. Then if you observe the portion, that is the coping portion, you can observe in this way, that is it is projecting actually outside. Okay, when you compare with this one, it is projecting outside, so you will get this value, that is 4.9, and this 0.4 likewise, and this width it is going to be 10 centimeter, clearly mentioned in the diagram. Okay, so after that we need to reduce those values. Okay, and before that you have to just multiply those values in the tabular column, that is this parapet coping, it is going to be two numbers, then 4.9 length, then 0.4 width, then the height it is going to be 0.1, so you'll get 0.39. Okay, then after that we need to deduct that some portions, that is going to be 4.8 meter, then it is height it is going to be 0.2, then width it is going to be 0.3. So actually these dimensions you obtained from these values actually. So if you observe here, you'll get the slab thickness it is going to be 20 centimeter, and this width it is provided as 30 centimeter, and the length it is going to be 4.8. Okay, so that is also clearly mentioned. So bearing of RCC slab in abutment, that you can easily calculate from this. So that is going to be 4.8 multiplied by 0.3, 0.2, and you'll get 0.57. After that you have to reduce those values, you will get the final 11 meter cube. Okay, so that is case of this first class brickwork. So we need to find out this each values for this abutments, wing walls, then parapet up to curb, then parapets above curb, and parapet coping, and after that you have to reduce this RCC slab in abutment. And here you can observe the slab, then we need to find out the slab quantity. For that, this value is going to be 4.8 meter, we already mentioned that value. Then slab thickness it is going to be 0.2 meter, and this width it is going to be 2.1 meter. How you got that 2.1 meter? So if you observe here, it is given 1.5 meter, and here it is going to be 1.5 plus 0.3, then 0.3. Okay, so both sides is 0.3 actually. So you are placing over this value, so you will get 2.1. Okay, so if you calculate those values, that is RCC work 1:2:4, slab excluding steel and all those values, that is you will get 2.016 meter cube. Regarding the some more steps are there, like the steel reinforcement calculations, then plastering likewise. So that calculations we will discuss in the next class. So with this we wind up today's session. Thank you.